All right, so this is the last topic in trig solving unit, and it's using sign charts with inequalities. There's a list of steps here that I'm not really going to walk through. I'm just going to start by showing the examples. The steps that we use it's basically what we did for solving trig equations, and then we kind of break off into using sign patterns. So I'm going to start this using the same similar techniques that we did before. So number 12 says, what are all values of theta from 0 to 2 pi for which 2 sine squared theta plus sine theta is strictly less than 0? So the first thing that we need to notice is that from 0 to 2 pi, at the edges of our domain restriction, they are inclusive. However, the inequality presented here is non-inclusive. So we'll have to be careful with that once we present our final intervals for this inequality. But how we want to start this is you want to look at, okay, what trig are we working with? Is it sine or cosine? Because that's going to change how you look at the relationship. For sine, we want to focus on quadrants 1 and 2 being positive, and then quadrants 3 and 4 being negative, because as we go into the positive direction, well, above 0, y is positive, and then below 0, y is negative. So we're focused on the vertical relationship here. So when we start this, we have 2 sine squared theta plus sine theta. And it's less than 0, but I'm going to approach it as if it's an equation. So again, we see that they have a common factor, which is sine. We don't want to divide and lose those solutions, so I'm going to factor that out. So if I factor out sine theta, I'm left with 2 sine theta plus 1, which is strictly less than 0. So now from here, when we solve trig equations, we break off and solve solutions for each of the individual parts. We will do the same thing here, but instead of using an equal sign, we will use the less than symbol. So I want to find solutions or intervals for when sine theta is less than 0. And I also want to find the solutions for when 2 sine theta plus 1 is less than 0. Now, if we were to sketch this out, we have our unit circle here in the xy plane. When sine theta is equal to 0, it's going to be at 0 and pi. And I should be consistent, so I'm going to use open circles. Now, sine theta will be less than 0 in quadrants 3 and 4. Okay, so over here on the left side, that is when theta is equal to pi. And then on the right side, I'm just going to say theta is equal to 0. Or I guess in this case, so that our intervals are consistent, we'll use 2 pi since it's inclusive. So my solution, or the angles that satisfy this inequality, will be from pi to 2 pi. But how I want to think about this is, if I were to plug in a theta that is from 0 to pi, so an angle from quadrant 1 or 2, it would not satisfy the angle. My sine theta would not be less than 0. It would actually be greater than, so it would be positive. But if I were to include theta that is between pi and 2 pi, it would satisfy the inequality because the sine theta would be less than. So I'm going to put a bunch of negative symbols down here, and then I'll have a bunch of positive symbols up here. And we'll see why here in a second. Actually, what'll make more sense is, and I thought about this teaching it this year, is I'm going to draw them along the unit circle themselves. So positive, and then these solutions will be less than 0. Now, if we do 2 sine theta plus 1 is less than 0, we have some algebraic manipulation. We'll have sine theta is strictly less than negative 1/2. So if I draw my circle in the xy plane again, the two angles that we are working with are, let's see, so sine theta is less than negative 1/2. So we're going to be at 7 pi over 6 and 11 pi over 6. So theta is equal to 7 pi over 6, and theta is equal to 11 pi over 6. So now what we're looking at is what angles or what thetas will satisfy this inequality. such that sine theta is less than -1/2. Well, if we start from 0, these angles in quadrants 1 or 2, they're not going to satisfy it because they are greater than 0, which means they will also be greater than -1/2. So I'm going to put a plus with all of these because they will not be less than -1/2, they will be greater. And then even if I plug in pi, I'm going to get 0, which is not less than -1/2, it's greater. Now, once we hit 7 pi over 6, that's when it changes. That's when we have angles that satisfy the inequality. So any angle that is from here, so 4 pi over 3, 3 pi over 2, 5 pi over 3, and we come all the way around to 11 pi over 6. Now, any theta that is greater than 11 pi over 6, that will not satisfy the inequality because it will be greater than -1/2. So this little interval here will be positive, okay? So that's how I wanted to start this one. Now there's a couple ways to approach this. You can overlap the circles if you want to, but a way that I teach it is to use a number line because we are more familiar with number lines. So let's start with our first inequality, which is sine theta is less than 0. We're going to call this one A. So if I draw out a number line, it looks like my endpoints are inclusive, but my inequality strictly says less than 0. So I'm going to have an open circle at 0. And then if I look at my first inequality, I have 0 and pi as I'll call them key points. So I'm going to put pi here with an open circle. And then we also have 2 pi. I'll do that with an open circle. Now, essentially what I'm going to do is I'm going to take my unit circle. I'm going to start at 0, and I'm going to break it apart from 0 and 2 pi and spread it out into a straight line, okay? So if I start at 0, I can see that this interval here will be positive. So it's this portion here. And I'll align the colors, like I had my purple here, and then I had my purple here. And this interval from 0 to pi was greater than 0. And then once I hit pi, it switches to where it will be less than 0. And I highlighted it purple, so I'll do the same here. And then I have the non-inclusive 2 pi here. And then this is all less than 0, so we'll call it negative. And then we'll do the same thing with the second inequality where it's 2 sine theta plus 1 is less than 0. We'll call this one B, and we'll do the same thing. So I'm going to open up into a number line. We have non-inclusive 0, non-inclusive 2 pi. And then this number line, we had 2 different key points. It was at 7 pi over 6, which is a little after pi. We'll make that an open interval. And then we also had 11 pi over 6, which is just before 2 pi. So I'm not only making a number line for each of them, I'm making sure that they are to scale because that's going to be very important for the next part. So from 0 all the way to 7 pi over 6, these thetas will be greater than -1/2. Or the thetas that we plug into sine will be greater than -1/2. So I'm going to plug in a bunch of pluses here. And then once we get to 7 pi over 6, it switches to where the angles from 7 pi over 6 to 11 pi over 6 that go into sine will be less than -1/2. So I'll do negatives for less than. And then that tiny interval from 11 pi over 6 to 2 pi, those will be angles that make sine greater than -1/2. So I'll do a plus. So now we have one more number line, which if you look at these, we have an inequality here and an inequality here. What do we do to get back to the original inequality? We multiply them together, right? Which is this intermediate step here. So now we're going to multiply these two together using their number lines and see, okay, what intervals will satisfy the original inequality, which is when these two factors are multiplied together into 2 sine squared theta plus sine theta and are strictly less than 0. So we're going to do A times B, and that's the third and final number line. So I have my non-inclusive 0, my non-inclusive 2 pi. And then I'm going to combine all of the intervals that we had from the other two. So I'm going to start with this pi here. We'll make that non-inclusive. And then I also have 7 pi over 6, which is non-inclusive. And then 11 pi over 6. So we're going to trickle down all of the intervals to the final one. Excuse me. So now let's take a look at these intervals. And I guess what I should do, go ahead and have the intervals extend up as well, just so we can easily see all of them. So if I look at this first interval from 0 to pi, this first part here with a, it yields a plus, and then this second part here with b yields a plus, and a plus times a plus, that will give you a plus. So that means our values in this interval will be positive or greater than 0. Now if we look at this next interval, in the first one it's tiny, but we have a tiny negative, that's going to be less than. And then if we go down, we have a positive, which means we will end up with a positive times a negative, which means in this interval, whoops, I don't know why I did -1, times a negative, which means we will have a negative interval here. So from pi to 7 pi over 6, it will be less than 0. The next interval, we have negative and a negative. So if we do negative times negative, we end up with a positive. So from 7 pi over 6 to 11 pi over 6, we will be greater than 0. And then this last tiny interval, we have negative times a positive. And that means from 11 pi over 6 to 2 pi, it will be less than 0. So for this one, we want the intervals where it is strictly less than 0. And that's going to be 2 intervals. So that will be from pi to 7 pi over 6, or 11 pi over 6 to 2 pi. And I haven't seen an example where it doesn't, actually that's not true. It's actually going to happen in the next example, so I'm going to ignore that. All right, so this next one is, what are all the values of theta from 0 to 2 pi for which 2 cosine squared theta plus cosine theta minus 1 is greater than or equal to 0? So now we have to switch our mindset because we're no longer dealing with sine, we're dealing with cosine. So now we're looking at traveling to the right will be positive, traveling to the left will be negative, because now we're thinking of our x coordinates. All right, so let's take 2 cosine squared theta plus cosine theta minus 1 is greater than or equal to 0. We want to factor this so that we can solve these factors individually. We have a quadratic. The a value is 2. So we'll have 2 cosine theta plus or minus some value. We want to multiply into -1. So we have a +1 and a -1, but the middle term is positive, which means whatever we multiply with the 2 has to be positive. Again, you always want to double check these. 2 cosine theta times cosine theta is 2 cosine squared. Positive 2 cosine theta minus cosine theta, we get 1 cosine theta. And then -1 times +1, we get -1. All right, so solving for these individually, we have 2 cosine theta minus 1 is greater than or equal to 0. And cosine theta plus 1 is greater than or equal to 0. Starting with the first one, isolating cosine theta, we end up with +1/2. So we'll set up our circle on the xy plane. And the two angles that we are looking at will be, let's see, it's pi over 3, and they will be inclusive, and 5 pi over 3. So we want to look at what intervals will satisfy this inequality. Well, if we think back to the previous video, we're looking at the x values, and if it was just the what the previous video was, it would be from 0 to pi over 3, and then 5 pi over 3 to 2 pi, all right? That's a great way to start, but the pink is what's going to satisfy the inequality such that cosine will have an angle that makes it greater than 1/2. So I'm going to say that from 0 to pi over 3, it will be greater than 1/2. And then after pi over 3, it's going to be less than 1/2. So I'm going to do minus, 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 all these minuses. And then once I get to 5 pi over 3, it becomes equal to 1/2. And then from 5 pi over 3 to 2 pi, we have greater than or equal to 1/2. All right, for the second one, we will have cosine theta is greater than or equal to -1. So we'll have our circle in the xy plane. Cosine is -1. That's going to be here. So when is cosine greater than or equal to -1? It's going to be all of the time. So the entire unit circle from 0 to 2 pi will satisfy this inequality because everything for cosine is greater than -1. If you think about how it oscillates, all of cosine is greater than or equal to -1. All right, so now let's do our number lines. The first one is going to be cosine theta. First one should be, actually, I'm going to do it like this. We'll call this A, we'll call this B. That way we're saving space. So for A, I'm going to have inclusive 0, and that's because of our inequality, and inclusive 2 pi. And then the key points in the unit circle for this one were pi over 3, and we will also include that, and 5 pi over 3. Again, try to do it to scale the best you can so that when we combine the two number lines, it's easier to see the intervals. So from 0 to pi over 3, it is greater than 1/2, so I will do a plus. And then from pi over 3 to 5 pi over 3, it is less than, so we'll do minus. And then from 5 pi over 3 to 2 pi, it is greater than 1/2, so we'll do plus, 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 plus. And then B. So we'll have 0 and 2 pi. And yes, the entire unit circle is included, but we do have a key point here, which is, I didn't mark it, I should have. It's theta equals pi. So you want to include that on your number line as well. And from all the way around, it looks like it will be plus because it satisfies the inequality. And I do all the pluses and minuses because if you just do one and then you're trying to like look at a specific interval, it can get a little confusing. So, but if you can remember, it's up to you. You don't have to include all of them, but it helps me to remember what is what. And then if we have A times B, again, this brings us back to the original inequality that we started with. So we break it down into number lines, and then we're basically combining it back again to number lines to solve it, combining the number lines to solve it, okay? All right, so I'm going to draw my number line. We're going to start with the 0, 2 pi. And if I look at A, I'm going to let it trickle down to inclusive pi over 3. The next one is pi. And I'm just going to go all the way. That way I can easily see where the intervals overlap. And then 5 pi over 3. All right, so with this one, I see we have plus times a plus. That will yield a positive value. The next interval, I have a minus times a plus. That will yield a negative value. And then in the next interval, I have a minus times a plus. that will yield a negative value. And then I have a plus times a plus that will yield a positive value. So in my previous example, when I was about to go off on a tangent, I was going to say, oh, I've never seen it not alternate. But then I remembered this example, it doesn't alternate. It does a bounce, okay? So this inequality is looking for when will it be greater than or equal to 0? Well, if we start with our first interval, we have inclusive 0 and pi over 3, okay? So we'll have 0 is less than or equal to theta, which is less than or equal to pi over 3. We'll also have this interval, which is 5 pi over 3 to 2 pi, both inclusive. And then this is why it's important that we included the pi, because even though on both sides it's negative, it's still 0 at pi. So we'll also say or theta is equal to pi. It's similar to the very first example that we looked at, where even though this is not included, sorry, this was in the previous video, where negative 2 pi was not included as part of the interval, but because the inequality is also equal to 0, we need to include it in our solutions. And if you're never sure, you can always plug it into the inequality and then see if it satisfies it, and then you can be sure. But as long as you overlap your number lines correct and you include your zeros, you should be good. That concludes trig solving. Hope this helps.